Okay, so we discussed curves yesterday and we will do the exercise today, and after that we will start doing the circles, the next topic. So first we'll solve a few questions of the exercise. Let me share the screen. Okay. Yes. So we can start doing it over here. Okay, for example, if we are given a question that you have to sketch a graph where y is equals to 5 minus x, x minus 1, and x plus 3. Yes. So how will we plot the graph for this one? Sketch the graph.
First the x. What do we say? The x-intercepts.
Yes.
It'll be 5, 1, and minus 3.
Yes, the x-intercepts will be 5, 1, and minus 3. Yes. What will we do after that?
We have to expand the brackets, like make the. No, wait. We
Yes.
know we would, yeah, after expanding, we know that the equation is cubic. It's a cubic graph.
Yes, this is a cubic graph. This is the other information that we know. Okay, what else do we know? I told you that you always need to ask 2 questions to identify that which type of graph do we need to draw. You always see 2, like you have to ask 2 questions. You have to identify 2 properties. What are those 2 things?
Whether it's what is it? What is the constant of the
Whether
like
the
the big
whether the
if it's
coefficient,
positive or negative?
yes, you have to check that whether the coefficient that is written with the dominant term, is it positive or negative. This is what we have to check. So in this case, is the coefficient that we have, is it positive or negative?
Will be positive.
Is it positive? You can see that if you multiply all the
I think
x,
it'll be negative. Yeah.
it would be minus x cube. X times x will give you x square, times x will give you minus x cube, because this one has a minus with it. So the dominant term that we have got is minus x cube. So we can see that the power, this is odd, and the coefficient that we have, this is negative. Okay. So which type of graph do we make in this case?
It'll have two curves. One
Yes, how
minimum, one
many?
maximum.
Very good. This is what we call as the turning points. So the turning points will be 2 in this case. And if we talk about the structure of it, what type of graph will we get? We made a grid yesterday, yes. So you can see it from here. If you have a degree which is odd, this one, and if the coefficient is negative, you get a graph which looks like this. So you, instead of starting from the top right, you will start from the top left, right?
Mm.
Yes, and the first thing that you will get, it would be a minimum. It would be a minimum point, and in this case, if you start from here, you will get a maximum, and if you start from the other end, you will get a minimum. So let's say we start from here. You should know that we will always get a minimum first. So drawing the graph, we have got our x-intercepts. So they are -3, it's 1, and it's somehow 5 like this. So you can see we will start from this end, which should cut the graph at this point. Is it giving us the information about the turning points, or is it just telling you about the x-intercepts?
We can also find out the y-intercept by making x equal to 0.
Yes, you can find that out as well. But right now, is it giving you the information about the turning points at these points where x is
No.
equal to 5, 1? Yes, it is only giving you the information about the x-intercepts and what would be the y-intercept. To find the y-intercept, we know that we have to make the x equals to 0. So what would be the value for y?
1 second. It'll be -15.
It would be 0, and 5 times -1, it would give you -5, and yes, it's -15. Very good. So it would be -15. So let's say if I say that this is -15, for example, so we can make it come at this point. After that, it will again go up, and it will again cut at this point. It's -3, it's 1, and it's 5. So it will go up, then after giving us a maximum, it will cut at this point, which is another x-intercept. So you can see we have got two turning points. This is the minimum and this is the maximum that we have got. This is how we are going to sketch it. Okay, let's take one more example. For example, we are given so we are given the question that y is equals to x plus 2 square and x minus 4 square. Yes, we have to sketch the graph for this one.
It'll be, the coefficient will be 4.
The coefficient would be the coefficient for what?
The highest,
With the
what was
highest,
it?
with the
Domain,
dominant term.
dominant term.
Yes. So it's not the coefficient, it's the power of the dominant term. It would be 4. This is what we call as the power. So this is the power.
The coefficient will be negative.
Why? Negative. It's not negative. This x is positive. This x is also positive. So when
Yeah.
you multiply both of them, you will get a positive coefficient. So you can see that the power that we got, it's even, and the coefficient that we have, it's also even. It's positive. Sorry, this is positive, So we will get a graph which would look like this. It would first give you a minimum, then a maximum, minimum, then maximum, and just like this. How many turning points will we have in this case?
5.
5?
No, wait, 3, 3.
Yes. It will give you 3 turning points. Okay. So the turning points, they would be 3. And at what points will we have the turning points? At what numbers?
4. No, wait. 2 and. No, minus 2 and 4?
2? Is it minus 2?
Not sure.
It's, you can simply say that you will get a turning point which will be at minus 2. Then you will get a turning point which will be at 4. And then the third turning point, you can draw it simply. Like the third turning point, it will be in between these two turning points. So you can roughly draw it. You don't have to get the exact answer. So these two, they will be the minimum points, because we know if you start from here, you will get a minimum first. So first you will draw a minimum, then you will get a maximum, and then you will get a second minimum at 4. If we draw it, it would be something like this. This is -2. This is gonna be 4. And we will start from here. It will, you have to draw a maximum point in between somewhere. So it would be like this. This is the graph that we will get. You can find the value for the y-intercept, obviously, and then you can pass the graph through that point, and you can make the maximum point roughly by knowing the y-intercept and in between these 2 points. So this is how you're gonna draw it, and if we see that we have x squared into x minus 3. Yes, in this case, what type of graph will we get?
Cubic.
Yes, very good. And what's the dominant term?
X cube.
Okay, this is x cube, and you have to again ask 2 questions. Is the power odd or even, and is the coefficient positive or negative?
The power is odd and the coefficient is positive.
Okay, very good. So it means that the graph would look like this. You have to start from the top right, and first you will get a minimum point and then a maximum. How many points, turning points, will we have in this case?
2.
2, very good. So we will, just a minute. Yes, so we will have 2 turning points. So what are these 2 factors giving us the information about?
The x-intercept is 3.
Very good. The x-intercept, it is giving you the information about the x-intercept. So the value for x, for the x-intercept, it's 3. And what about this one?
0. But there's no intercept.
Yeah, but this is giving you the information. This is not giving you the information about the intercept. Then what is this factor telling you about? It has a square on it, and I told you that whenever a factor has a square on it, it tells you the information directly about the turning point. If you have a factor which has a power of only 1, just like it has in this case, it gives you the information about the x-intercept. But whenever you have a factor that has a square on top, then we say that it gives us the information about the turning point exactly. So from here we can see that the value for x it's 0. So we will have a turning point at 0. Turning point at 0. So if we draw it, this at this point where the value for x is equals to 3, we will have it as an intercept, and this is the origin where the value for x and y, both of them, it's 0. You have to start drawing it from this end because the coefficient is positive, so we will start drawing it from here. You will pass it through here. Because we know that it will give us two turning points. So the first turning point would be in between these two values, which is a maximum point. So it means that the second turning point, it must be at 0. Is it clear?
Yeah.
Okay. Okay, moving forward, we will talk about circles now. Okay. So if we are given a circle and we are given any point that exists on this circle, obviously we know that uh, if, for example, if the central point of this circle is at the origin of our quadrants, all of its points, they will have some values for x and y. Like they will have the x coordinate and the y coordinate as well, all of them. So to find the relation between the x and the y coordinates of any point that exists on the circumference of the circle and the radius of that circle, we have a formula that we use. It's, for example, you can see that in this case, the central point is at the origin. So at this point, we can say that the center, it has the coordinates 0 and 0. The x coordinate and the y coordinate, both of them, they are at 0. So in this case, we use the formula to find the relation. It says that x square for all the points that exist on the circle, it will be true for all those points. It says that the square of the x coordinate of any point plus the square of the y coordinate of any point of the same point which we are talking about is equals to r square. So this is the formula that we use. When do we use it? We use it when the center is at the origin. When the center has the coordinates 0 and 0. But what if we say that, for example, if we move our circle to any other point, for example, if I say that I have moved my circle somewhere in between in the quadrant 1, somewhere over here, and the center of this circle, it has now got the coordinates which are a and b. Its x coordinate, I am generalizing it as b a, and its y coordinate is b. So now to find the relation between the radius and any point that exists on the circumference of this circle, we can use the formula. So this is the formula that we use when it's in the center, and if it has any other coordinates, where we say that the center, it has the coordinates a and b. So in this case, the formula that we use is x minus a square plus y minus b square equals to r square. So this is the second formula that we use. This is what we call as the general form of a circle. And if I want to expand it, I open up the brackets and I solve it further, I can get the standard form as well. So the circle, any circle, it can also be represented in its standard form, which is this. And it's x square plus y square minus 2ax minus 2by plus a square plus b square minus r square, which is equals to 0. Okay, and you can also write it as x square plus y square plus 2gx plus 2fy plus c equals to 0. So what we have done over here is we have simply replaced g in place of minus a, and we have simply replaced f in place of minus b, and we have simply written c in place of this complete term. So from here, from this form, you can simply conclude the information that the center, it will have the coordinates minus g and minus f. Or if you are written the equation in this form where it's minus a minus b, you can say that it will have the coordinates a and b. And if it's written in this form, like plus 2gx plus 2fy, then you can say that the center, it will have the coordinates, it will be minus g and minus f. For this, from this equation, we can conclude this thing, that the center has this coordinates. Okay, now if we see that, let's say we are given any equation, let's take an example. For example, you are given the equation x square plus y square minus 6x plus 10y minus 15 and it's equals to 0. And you are asked to find the coordinates of the center and the radius of the circle. You have to find the center and the radius as well. So which form is this one? Is it the standard form or the general form?
Mm, is the general?
Yes, this is the standard form. This is in this form. You're given it in this form. This is the what we call as the general form. For example, whenever you are given a general form and you are asked to tell the center and the radius, what you do, you can first convert the general form into the standard form. This is what we call as the standard form.
Mm.
Sorry, this is the standard form and this is what we call as the general form. This one. So first you have to convert the standard form into this general form. This is the general form and this is the standard form that is given. So first we have to convert it. So to convert the standard form into the general form, which formula do we use? We use the completing square method.
Mm.
So use the completing square method. Okay. So from the question that is given, what we have to do is we have to complete the square. First we will write the x terms side by side and the y term side by side, and you can move the constant on the other side. So the equation would become x square minus 6x. It would become x square minus 6x. Then we have plus y square plus 10x, and it would be equals to 15. Now we have to complete the square for these two terms where the variable is x, and complete the square for these terms where the variable is y. How do we complete the square? How can I write it down? If I want to complete the square for these two terms, what would it be?
Mm. 1 second. It'll be x minus 3 square, the whole square.
Very good. It would be x minus 3 whole square. And will we get any constant as well?
1 second. Yeah, we'll get square 9 plus 9. No,
No.
minus 9.
Yes, that would be minus 9. And what for the other one?
It'll be x plus 5 the whole square, y plus 5 the whole square,
Yes.
minus 25.
Yes, it would be minus 25 equals to 25. Now we have to simply move our constants on the other side so that we can convert it into the general form. So it would become x minus 3 whole square plus y plus 5 whole square equals to, here we have to convert, we have to move them on the other side. So we will get 49. Now you can see we have simply converted it into the general form, and using this general form, now we have to tell what will be the coordinates of the center and what would be the radius.
Mm,
Yes.
1 second. The radius will be 9. Oh, sorry, no, 9. 49.
No. I told you that
Oh,
the
sorry, no, 49.
it's
It'll
r
be
square
7.
represents
7.
r square. Yes. So from here we can see that r square it's 49. So to find r we have to simply take the square root. So the radius would become 7. Okay. And what about the coordinates of the center?
It'll be 3 and minus 5.
Yes, very good. It would be 3 and minus 5. Okay. After understanding the general and the standard form, you need to know a few properties of a circle. The first property is whenever you have a right angle inside a circle, the hypotenuse of that right angle will be the diameter of the circle. This is what you need to know. Okay, so this is the first property. So whenever we have a right angle at any point on this circle, for example, if I say this is the central point and I say that I have a right angle that is inside here and it's like this. So the hypotenuse of that triangle, it will always be the diameter. You can see that the hypotenuse for this right angle, it's the diameter of the circle. This is the first property. Hypotenuse of a right angled triangle is the diameter it's the diameter of the circle. Okay. The other thing that you need to know, okay. So the second thing that you need to know is that the perpendicular from the center of a circle to any chord that is drawn in a circle, it bisects that chord. If I am given any circle and I draw any chord between it, what's the chord?
Chord is, what was it?
It's simply a line.
It's just a line from like one end of the circumference to another.
Yes. Simply a line that cuts the circle at 2 points. So this is like this or like this. So you need to know that whenever you draw a perpendicular line from the circle to any chord, it will bisect that chord. Bisect means that it will cut it into two equal parts. So it means that if this is point A, this is point B, and this is point C, the length of AB would be equal to the length AC. Perpendicular from center Any chord bisects it. Bisects means to divide into two equal parts. Okay, this is the second property. And the third one is the third one says that the tangent to any point on a circle, it's always perpendicular from the center of the circle to that point. So whenever we draw a tangent line, a line that cuts the circle at any one point. So if I draw a tangent at any one point, it will be always perpendicular to the radius that will be drawn from the center of the circle to that point. It will be always perpendicular to that. So it would be a right angle or an angle of 90 degree. Okay, so the tangent is always perpendicular to the radius of circle at that point. Okay, now let's take a question. Mm, okay, let me write the question, but okay, there's one more thing that I need to tell you. Just a minute. Okay, if we want to check the intersection of two circles, that at how many points the two circles are actually intersecting, we have got different possibilities. For example, if I am given two circles, uh, this is, for example, circle A and this is circle B. There are so many different possibilities. It's also, this is like one of the cases that they only touch each other at a single point, and they are touching each other externally, like they are placed outside each other and they are touching only at a single point. This is one of the possibility. Then we can also have another possibility where the two circles, they are intersecting each other at 2 points. So over here you can say that they are cutting at this point and at this point as well. This is another possibility. But if we have the two circles and one circle is inside the other circle, and in this case as well they are also touching each other at only one point, but this time they are touching each other internally. Then there is also a possibility that they are not touching each other, they are just placed far apart from each other, and another possibility is that they are placed inside each other, and in this case as well they are not touching each other. So how can we identify the intersection of two circles? If we are given the equations for any two circles and we are asked that how many points are the two circles touching each other, how can we identify that? Let's take an example. For example, I am given the equations. Let me just write the equations. Intersection of two circles. Okay, let's take an example. If we are given the equations x minus 4 whole square plus y minus 5 whole square equals to 16, and the second equation for the second circle, it's x minus 3 whole square plus y minus 3 whole square equals to 4. And you are asked to tell that how many points are these circles intersecting at each other. How can we identify that? In the very first step, you have to find the distance between the centers of the circle. So how do we find the distance between the centers of the circle?
Mm, It would be 3 and minus 3, right?
First, you have to find the
Oh, wait.
centers. Obviously, first you need to know
Hmm.
the centers, and then you can use the distance formula which we have been using until now, and we will find the distance between these 2 points. Because we know that the centers of any two circles, they are simply the 2 points. So we will use the same formula, the distance formula, which is d is equals to square root x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula that we are going to use to find the distance between the centers. So in first step, you have to identify the centers, and then we will find the distance between the centers. So for example, if I say this is circle 1 and the next one is circle 2, you have to tell me the radius and the coordinates for the center for both of these circles. What's the central point for circle 1?
4 and 5. 4, 5.
Yes, very good. The center will be 4, 5. What about the radius? Let's say we call
It's
this
8.
as C1 and the radius is R1. Is it 8? No, it's not. It's not 8. You have to take the square root of 16.
It's 8. Oh, wait. Oh, no, sorry. 4, 4.
Yes, it will be 4. So, center 1, it has the coordinates 4 and 5, and radius 1 is 4. What about the second circle? It will be the central point. What will be the central point?
3, 3.
Yes, and radius. Let's call it as radius 2. And what's the value for R2?
2.
It's 2. Very good. Okay, now we want to find, this is the step 1 where you have to identify the centers and the radius. This is going to be step 1. In step 2, we will use this distance formula to find the distance between the centers of the circles. So if we substitute the values, it would give you 3 minus 4 or 4 minus 3, 1 square will be 1 plus 2 square would be 4. So it would be square root 5. Okay, this is step 2. In step 3, you have to find two things. First, you have to identify or you have to find R1 minus R2. And what is it? R1 minus R2.
Hmm. 1 second.
R1 was 4 and R2 was 2.
It's 2.
Okay, so this is gonna be 2. And then you need to find R1 plus R2. And this is gonna be, what would be the value for this one?
6.
Okay, very good. Based on these three things that we will calculate, the first thing will be the distance between the centers. This is the first thing. Then you have to find the difference of the two radii, and then you have to find the sum of the two radii. And after calculating these three things, you will check different possibilities. We will see the cases. Case 1 or the possibilities or the cases. For example, we get for the case 1, if you get the value of this d, I'm representing as it as d, the distance between them. So if its value is greater than r1 minus r2 but less than r1 plus r2, it represents that the circles, they are intersecting at 2 points. This is the first possibility. 2-point intersection. 2-point intersection. Then in case 2, if you get your distance like d equals to the sum of the two radii, it represents that the circles, they are touching at only one point but they are present outside each other, so you can call them as externally tangent. Circles are externally tangent when the distance is equals to the sum of r1 plus r2. So it would be this scenario, this one. Yes, this one, the first one, that they are touching at only one point but they are present outside each other. In this case as well, you can see that they are only touching at a single point but they are touching internally, but in this case they are touching externally. So the circles are externally tangent to each other. In this case, touches at one point, externally. You can note down these cases because I guess they are not written in the book, I'm not sure. which is at one point externally. So you can say that the circles are externally tangent. Then after this, if we have d which is equals to the difference of the two radii, in that case we say that they are touching each other at one point, but this time they are touching internally, so we call them as internally tangent. So this is case 3. R1 minus R2. What does these two bars represent?
Uh, the answer will always be positive.
Yes, it means that whether even you get a negative symbol, you can skip that and you have to only pay attention to the magnitude. So it represents that they in this case they are touching internally and the circles are internally tangent. If d is greater than the sum of them, it represents that there is no intersection and they are far apart from each other. And if d is less than r1 minus r2, it represents that there will be no intersection and the circles are inside each other. In this case, they will be far apart from each other, and in this case, they will be like this. the last one where d is equals to 0 or r1 is equals to r2. You can see that we are talking about the same circle. So we have the same circle, so infinite number of intersections will be there. Is it clear?
Yeah.
Okay, we will continue it tomorrow. Let's end it here now.
Okay.
Okay, Allah Hafiz.
Allah Hafiz.